to study how do metal reacts with non-metals. So here are some examples of some non-metals. Here you see carbon, fluorine, nitrogen, oxygen, phosphorus, sulfur, chlorine, hydrogen, bromine, iodine. All these are non-metals, and some metals which are given here: potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, etc. All these are metals. Now, how do these metals react with non-metals? Generally, when metal reacts with non-metals, they always form, ionic compound. So let us see with an example, sodium and chlorine. How do sodium react with chlorine? So for knowing all these things, we will have to go back a little bit to class 9. In class 9, you have already studied the atomic number of sodium is 11 and chlorine is atomic number 70. And now we will go back to electronic configuration. Electronic configuration means distribution of electrons in the various orbit. Systematic distribution of the electrons in the various orbit. So systematically, when we distribute, the first orbit can accommodate 2 electrons. The second orbit can accommodate 8 electrons. So 2 plus 8 is 10. So how many electrons is left out? So left out electron is 1. So this is called the valence electron. So for chlorine also, let us distribute it. The first orbit will get 2 electrons. The second orbit will have 8 electrons, and the third orbit will have 7 electrons. 2, 8, 7. So let us now see that how do they react. We will represent in the electron dot picture. So this sodium will react with chlorine, and I will show you the electron dot picture. So when you draw in the electron dot picture, you will always represent only the valence electron. I repeat again, when you represent the ionic molecule, formation of the ionic molecule between sodium and chlorine, you will represent only the valence electron. That is, this electron is called valence electron, and this electron is called valence electron. So we will represent only the valence electron in the diagram. So sodium has got how many valence electron? 1. So we will represent as a cross. Chlorine has got how many electron? 7 electron. We will represent in dot. So why we represent in dot and why we represent 1 in cross? 1 should be represented by cross and 1 should be represented by dot, to distinguish that sodium element is different from chlorine element. Chlorine is different from sodium. So sodium has got 1 electron, so sodium is given as a cross, or you can represent this dot here and cross here. It does not matter. It does not matter that whether you represent chlorine as a cross and sodium as a dot. Sodium you can represent as a cross, chlorine you can represent as a dot. So now this sodium will donate 1 electron to chlorine and fulfill the octet rule. I think you still remember the octet rule of class 8. Octet rule of class 8 is that when any element combined with another element, it will either donate or share its electron, and the last cell should always have 8 electrons in its outermost cell. That is called octet rule. So now sodium, after donating 1 electron to chlorine, sodium has got 2 8 electrons, and chlorine will at last will have 2 8 electrons. So both of them are fulfilling the octet rule. Sodium thereby giving 1 electron, sodium becomes sodium plus iron. Chlorine accepting 1 electron, chlorine becomes chlorine minus iron. Now you may be asking a question, sir, why sodium becomes sodium plus and chlorine becomes why chlorine minus? So the answer is that sodium has got 11 electron, 11 atomic number 11. It means that it has 11 electron and 11 proton. I repeat again, the atomic number of sodium is 11. It means that sodium has got 11 electron, which is negative charge, and 11 proton, positive charge. So when sodium donates 1 electron, so it has given already 1 negative charge to chlorine. but leaving one positive charge more in the nucleus. So sodium is becoming plus here. Now chlorine atomic number 17 means it has 17 electron and 17 proton. So when one electron comes from sodium, you add it 1. So 17 plus 1, 18 electron becomes, but the positive charge remains the same. So increasing one negative charge more, so chlorine becomes minus. So there is a strong electrostatic force of attraction. There is a very strong electrostatic force of attraction between this positive charge and negative charge, that is positive ion and negative ion, that led to the development of sodium chloride molecule. So here are some more few examples of ionic compound. Here is magnesium. How do magnesium combines with oxygen? So here magnesium atomic number, we know its atomic number is 12. Oxygen atomic number is 8. Its electronic configuration is 2, 8, 2. Oxygen is 2, 6. So we will represent now them in the electron dot structure. So magnesium with what representation you want to represent? Either by cross or either by dot? You tell me. Okay, let us represent it by dot here. Magnesium, 2 electrons, 2 dot. Oxygen, 6 electrons in the outermost cell. Let us represent it by cross, since we have represented here by dot. So here is cross, cross. How many electrons? 1, 2, 3, 4, 5, 6. So here, magnesium will donate these 2 electrons to oxygen to fulfill the octet rule. Here, if 2 electrons will be donated, here 2, 8 will be fulfilled, and here, accepting the 2 electrons, it will form 2, 8. So magnesium has donated 2 electrons, so magnesium will be plus plus, or you can write magnesium 2 plus, plus plus also you can write 2 plus also, and combining with oxygen, oxygen will be minus minus, or you can write oxygen 2 minus. So here, why it is plus plus? Since it has donated 2 electrons, so 2 negative charge is gone, but in the nucleus 2 positive charge remains more, so it becomes plus plus. Here oxygen is having 8 electrons here and 8 protons, so when 2 electron comes, so it has become 10 electrons, so making it here 2 negative. So this positive ion and this negative ion will form a molecule called magnesium oxide. Let us take one more example of magnesium and chlorine. How do magnesium react with chlorine? So magnesium atomic number is 12, chlorine atomic number is 17, its electronic configuration is 2, 8, 2, and here is 2, 8, 7. So electron dot picture will be represented as magnesium 2 electron, but chlorine will be represented as 1, 2, 3, 4, 5, 6, 7. So here magnesium will donate 1 electron to chlorine, but what will happen to this extra 1 electron of magnesium? So magnesium will combine with 2 chlorine atoms, so 1 more chlorine atom will be required. Here 1, 2, 3, 4, 5, 6, 7. So magnesium will combine with 2 atoms of chlorine. So the 2 electrons of magnesium will be donated to 2 chlorine atom, each 1, 1. So here magnesium has donated 2 electron, so magnesium will be plus plus, but here 2 chlorine, so 2 chlorine is accepting its 1 negative charges. So when the molecule is formed, it will be written as magnesium chloride MgCl2. We are coming to the properties of ionic compound. So here the properties of ionic compound is, ionic compounds are generally solids because they are formed between positive ions and negative ions. So question is, why these positive ions and negative ions, when they combine, why they form solids? The reason is that there is a strong electrostatic force of attraction between the positive ion and negative ion. that makes the molecule very rigid. That's the reason that they form solids. So, question will just not come in the examination that write the properties of ionic compound. But the question may twist and give you that why the ionic compounds are solids. So you can hear the answer is within this. The molecules are formed of positive ion and negative ion. Since they are formed of positive ion and negative ion, there is a strong electrostatic force of attraction between the positive ion and negative ion that makes the molecule very rigid, and so they are solids. Second properties is that ionic compounds have high melting point and boiling point. Ionic compounds have high melting point and boiling point. Here also the question comes, why they have high melting point and boiling point? So I told you here the first point is that they are formed of positive ion and negative ions. So since they are formed of positive ions and negative ions, they have a very strong electrostatic force of attraction. So to break up that strong electrostatic force of attraction, a large amount of energy is required to break up that electrostatic force of attraction. Therefore, they have high melting point and boiling point. The third point is ionic compounds are soluble in water but insoluble in organic solvents such as kerosene, benzene, toluene, etc. etc. Now you see salt, when you put in the water, it gets dissolved in the water. So salt is a ionic compound. It generally gets dissolved in water, but insoluble in organic solvent like kerosene, benzene, petrol, etc. The fourth point is ionic compounds are good conductor of electricity. Number 4 point is ionic compounds are good conductor of electricity in molten state. So ionic compounds are not good conductor of electricity in solid state. They are not good conductor in solid state, but they are good conductor in molten state. So since the ions break up, okay, here also question will come, why ionic compounds are good conductor of electricity only in molten state. So it's very easy, because in molten states the positive ion and negative ions break up, and that positive ion or negative ion are the carrier of the charge which conduct electricity.
Stay home, stay safe.